Alright, time for another DraftPhysics.com, DebatePhysics.com also, but not enough debate tours available. No one will really interact. This guy, Dr. Lincoln, did in comments barely interact. I think this video was actually made because of an issue I brought up. Well, at least his whatever you want to call it, his clarification that he'll go into more detail in a future video, blah blah blah, was provoked by my comment, but there was no evidence produced, and that's the only thing that really matters here. If you're going to claim that kinetic energy 1/2 mv squared is a real thing, then you should be able to produce really good experimental evidence demonstrating it somewhere where it's collected, where it actually does work. But no examples. Zero evidence. Really bad science. So anyway, he really doesn't know anything about the whole how energy works. All the physicists seemed incredibly clueless that obviously it's a conservative system. The fact is gravity makes things hot. The heat radiates. The heat's creating the pressure that makes gravity, which causes things to get hot, and it's a cycle. And they really just don't get any part of that. Because they really don't think heat is the same as momentum. It's the same stuff. You have to account for it. It's not some different kind of energy. It's motion. It's momentum. Same thing. Anyway, let's play the video. I believe we can just play it. Sorry, I have to check. Yeah, it should be somewhere close to correct volume.
Energy is one of the more fundamental concepts of both classical and modern physics. But just what is energy?
So it's just motion. That's all it is. So the force has it because it has motion. It has some sort of mass. Now they claim the forces don't have any mass, but obviously they have momentum. So really, there's no argument here. Rest mass is nonsense. Fact is, they have the capacity to exchange momentum, and that's what they do. So anything moving is displaying its possession of something called energy. So the force has all the energy, and it shares it with matter now and then. So matter is dead, the force is alive with energy.
That's an excellent question with a lot more to it than you'd think. Every time.
So there's less to it than they think. So that's the funny part. Newton was right. It's really simple. MV. Galileo, Descartes, Newton, they all knew what this quantity of motion stuff, and basically they already had the idea that it's all circular.
When you look at it, you learn something new.
It just moves from thing to thing, and that's all that can happen. You can just make the energy go from one thing to another thing. Period.
Let's see if I can surprise you.
All this bullshit. Wasting my time. Waste your time with bullshit.
Energy is easier to recognize than define.
All right, so it's easier to recognize than define? No, it's easier to define, understand, than to see it as it is. So if you understand it, that, okay, anything that's moving had to be pushed by something. It had a history. The Earth is going around the sun. Well, it couldn't have done that unless something pushed it. Everything has to be, you have to account for the presence of its motion, and its motion has a history, and the history is circular. It goes into a sun, and then the sun eventually blows up. It comes back out again. It's just a cycle.
You know it when you see it, like a speeding race car, a taut bow, and this may be the...
So this is kind of the sillier part where, you're taking whole complex systems and then saying, well, I understand the energy in that system, when you really don't. All right, because the bow has to do with the atoms being stretched, and that means atoms being pulled apart from each other, and they're bound by charge, and and all you're really doing is pulling a magnet. In a sense, you're pulling two magnets apart, and so you've created the circumstance where they're going to want to push back together. And the key point is push. It's a push averse. Everything that happens is pushing, and so if you take away a push and there's still a push on the other side, obviously it looks like it's moving in your direction for no good reason, but there is a good reason.
most energetic thing known to man, a group of 4-year-olds have been fed espresso and a bag of gummy bears.
All right, so I've already done this video, and I'm just doing it again because it's just so bad, frankly. I mean, it brings up this Chardonnay's fraud experiment, and, you know, these are physicists. They should be able to recognize when an experiment is just a piece of show art. It's deceptive. It's not telling you the truth. And denting clay with round objects is not telling you the truth.
Scientists try to make the definition a bit more precise and say that energy is the capacity for doing work.
Right, which means absolutely nothing because they don't consider work to be any kind of action. So heat isn't work. Lots of things aren't fit into the category. So work basically is some category where it has some use to human beings. And that's not the definition of energy. Energy is just motion in the universe. Anything moving has energy. Things not moving don't have energy. Really that simple.
That doesn't help most people, as physicists use the word.
In its rawest form, it's moving the speed of light as a quantum of force. In its more complex form, it's pushing electrons and protons. That's it. Those are the two states it can be in. Pushing an electron or proton, or freely flying. And you can just, from that simple diagram, you can understand that, well, the more energy that's pushing electrons and protons, that is, the hotter I make suns, the less energy there is out there. And the less matter being compressed by suns, the more force that's out there.
Work in a technical way. Colloquially, I think that you might call energy a property of things in motion.
So it's not a property of things in motion in the sense that it's just the motion itself. Anything moving has energy. And again, there's only two states for it elementally. It's either freely flying at the speed of light, or it's going some slower speed pushing a bit of matter. I'm just letting you in on the real truth. Okay, I'm sorry, you know, that they don't know it, you don't know it, but frankly, that's how it really works.
Something that could, in principle, cause something to move. There are many
So there's no in principle cause something to move. That's kind of just bogus. The Mississippi River has obvious energy because we can see it moving. All right, we don't have to talk about potential because we know it's very kinetic. And all you can do is throw a boat in it or not throw a boat in it. And the same is true for gravity. You can allow something to fall in gravity, or you can hold it with a string and keep it from flowing with the river. You know, your choice. But there's no such thing as anything called a potential energy. There's just streams to be tapped. There's flows of energy, and you can stick your finger in it and pull out some of the energy.
Different kinds of energy. For example,
so there's no different kinds. So potential is nonsense. Kinetic is nonsense. Thermal, that's really just momentum in atoms. It's not complicated. Electrical,
potential,
a momentum in electrons. Chemical is just the idea that when you bind atoms, they have all kinds of configurations with each other, and the fact is that you can knock a bit out, and then two charged elements will repel the magnets. So that's just like saying that I could take a bunch of magnets and put them together, and I could flip one on the inside, and that would cause all the others to flip. So there's capacity to move in the binding energy between objects. And then nuclear, again, is the same. Chemical and nuclear are essentially the same thing. The nuclear energy is just talking more about the nucleus of the atom, where the chemical is more about electrons on the outside of the atom. And the etc. is just, why bother? You're a physicist, a scientist. There's no etc.
Kinetic, thermal, electrical, chemical, and nuclear, to name a few. The big categories are kinetic and potential.
So there's no such thing. They're both fake words for fake concepts. There's quantity of motion. There's momentum. Not on the list. Kind of funny.
Kinetic energy is the energy of motion, be it translational.
So we know that that's not true. It's a silly formula that's a piece of crap that was never demonstrated with any good evidence. And the truth is, momentum is the energy of motion. It's about just assessing how much mass does it have and how fast is it going. That's how you quantify energy.
Which is a fancy word for, moving, or things like vibration or rotation.
So all of those things are just motion. Rotation is motion. Vibrating is obviously motion.
The first kind of kinetic energy you learn about is translational energy. If you have an object of mass m with a velocity v, then the translational kinetic energy is 1/2 mv squared.
Okay, so that's not what I learned. So it's not the first thing I learned. I first learned about momentum, and all the physics lectures, frankly, always start with momentum. So that's sort of bogus. That this is what you start with. It isn't what you start with. It's a contrivance thrown in later to sit there and just make an absolute mess of something that works perfectly. Momentum gives you really good answers, always good answers, and this is just silly mush. Again, Newton wouldn't have written the third law, okay, equal and opposite reaction, if there was any notion of this being true, this kinetic energy nonsense, because obviously there's lots of reactions, actions, where there's no equality. The bullet, 2,000 joules. The gun recoil, 2. I mean, it's 1,000 to 1 difference. Why would he write the third law if you can have an explosion where you have 1,000 times more energy going one way than the other way? I mean, come on. It's just so obviously has no continuity. Okay, there's just no this is a complete change in how you would understand energy. This idiot notion that somehow velocity matters. And so I've used the comparison, but obviously they don't do this with amperage and voltage, which is very much a parallel to mass and velocity. And obviously it would make no sense at all in electrical circuits if they thought the velocity squared was a real thing.
By the way, a future video will explore that equation in much more detail.
So it was just a big pile of steaming crap where he just played his derivative nonsense. He didn't show us any evidence whatsoever that this piece of crap gets a right answer anywhere.
Potential energy
Didn't land man on the moon. Momentum landed man on the moon because thrust can only be understood as mass moving a velocity. NASA scientists will tell you that. Now, they won't tell you that direct statement, but they'll tell you in the sense that anytime they're going to describe what you can do to move, they're going to talk about you taking a piece of mass and throwing it, okay, letting it go in a direction, and that will make you go in the opposite direction. They're big third law believers. All right, so potential energy is stored energy. So storage is always active storage, so it's always energy has to be in the form of force, and there's no other way to quantify it. It's not dead, so you have to be careful with that word, and it's stored as motion somewhere, and it has to be motion inside the atom or motion somewhere.
is stored energy. It's usually created when an object is moved against a force, like stretching a spring or lifting an object.
So it's not against a force, and that's more silly talk. All right, so it says the strength of the force, distance moved. Now we know that it's not about the distance, it's about the time. How much time are you experiencing the force? How much time are you in the rain? How much time are you in the sun? These are things that will decide how wet you get or how suntanned you get. And the same is true for energy. How much you will collect will be dependent on how long you're exposed to the radiation.
Against gravity. It's called potential energy because while the object isn't moving, it will if you let it go.
So again, and it doesn't have anything to do with the object having any potential energy. The object doesn't have any potential energy. The thing you're putting it in has potential energy, has energy, period. And you're just going to stick your water wheel in the stream. I mean, it's kind of silly to say the water wheel has potential energy when it's sitting above the water. And then I lower it into the water and all of a sudden it did something. No, the water's doing something. And the wheel is just taking some of what the water's doing.
Potential energy generally depends on the strength of the force and how far you move an object in the force field.
So that's the nonsense part. It has nothing to do with how far you move the object, so it doesn't make any difference whatsoever. If I have a speeding bullet heading for Earth, it's going much faster than the gravitational acceleration. It goes through the gravity very, very fast. It gains absolutely nothing. If I have a motorboat and I plow downstream, I won't gain anything from, barely anything from the water, because I'm plowing through it very fast. The water doesn't have any time to push me at all. I'm not going to gain anything from it. It's just a fact. You can't extract the energy based on distance. You have to extract the energy based on time being exposed to the force and the strength of how much friction, how much contact you have with the force. If I hold the boat above the stream can't make it go anywhere.
The most familiar form of potential energy is gravitational. If you lift an object and drop it.
So again, there's absolutely no potential energy in the object. It's just kind of deceptive to talk about it that way. And what it is a very constant flow of water. And you're just putting different boats in the water, and the different boats will be pushed based on their surface area. And in the case of gravity, it's instead of surface area, it's just mass. So the heavier object will collect more because it's heavy. It's got a high mass, and the lighter objects will collect very little. And when they hit the ground, you'll see that the light object will go poof, and the heavy object will go bang. Big difference, because they're going to collect a different amount of energy from the stream.
It moves downward. Lift it higher, which means move it longer distances against the...
No, it means letting it be exposed to the force for a longer time. It's 9.8 meters per single 1 second. So this is just such a canard and a lie to sit there and talk about distance. So we're all the way back to Leibniz just claiming 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet. He's not going to prove that. There's no evidence that's true. And they just keep saying it. And they have no physical evidence supporting their theorem.
Force, it gets more potential energy. And, of course, that means when it hits the floor, it's moving faster than if you only lifted it a little bit.
We know it's going to go faster based on how long it's in the force, and it's going to be proportional to its mass, how much energy it has. But speed will always be the same, because big things collect more force, little things collect less force.
Think of energy as being a concept that originated with Newton, but it didn't start with him. He thought the important thing to describe motion was what we now call momentum, which is...
Right, so to all the naysayers, this is one of the reasons why I decided to play this again, these people saying Newton believed in 1/2 mv squared or mv squared. So here's Dr. Lincoln telling you that that's not his understanding of what Newton believed.
Is just equal to mass times velocity.
Yeah, so the same for Descartes and Galileo and all the other scientists of the time.
On the other hand, a contemporary and rival by the name of Gottfried Wilhelm Leibniz championed something closer to what we now know as energy.
So Huygens said it first, Leibniz, who did steal everything, including Newton's calculus. He was a thief. Just took Huygens' idea and used his bigger mouth, and I pretty much is all you can say. So he just amplified a piece of crap.
He thought the quantity that mattered was mass times velocity squared.
He thought it. He didn't have any evidence of it. So again, and the lever proves it to be nonsense. Lots of thousands of year-old ideas prove it to be nonsense. It's completely inconsistent. You can't, anytime you exchange energy between something of different masses, you can't conserve both quantities.
The reasons for the two positions were largely philosophical.
So again, he's trying to pretend it isn't overtly a complete different definition of the cause and the effect. So no, it's a completely different definition of the physical universe. It's not just a philosophical disagreement.
And it took a French intellectual by the name of
So, a slut, not a, I don't know, it's a funny word for slut, is, intellectual, but regardless, an accomplished woman, okay, but again, theater, okay? It's not good science. Every experiment she did was theoretically flawed as a way of getting to the truth. And the denting clay with round objects was so obviously flawed. It's like saying because I pointed an arrow and it goes deeper into something with the same force, I use the same force, but the one with the pointy arrow goes in deeper, that it has more energy because I pointed it. It's that stupid.
Émilie du Châtelet to sort it all out.
She didn't sort anything out. She just created noise experiments, okay, to confuse and deceive.
By dropping steel balls into a bed of soft clay,
So it wasn't steel. They were brass and lead, but regardless, she dented the clay, okay? They didn't penetrate into the clay. The surface went into the clay. So one of them, obviously the clay, one of them is, as a diagram, much flatter than the other one on average. So it really is just as simple as saying, here, I'm going to take a pointy arrow and compare it to a flat arrow, and I'm going to decide which one has more energy. Obviously, that's not going to work. It's not going to give you the right answer.
found that the depth that the balls penetrated.
So it wasn't the depth, it was the displacement. And obviously, on a circle, the displacement gets wider and wider the further in you can go. So obviously something with twice the velocity is going to push clay further, okay, which means there's going to be a bigger displacement. And if you want to do a fair fight, you have to drop a flat surface and a flat surface, not a round surface.
Depended on the height from which she dropped them and the square of the velocity at which they hit the ground.
So absolute crap experiment. He just cited it as an authority. This is just like when they talk about the Eddington experiment proving something. This is crappy science, okay? This you don't do. You don't sit there and gild dog do. It's garbage experiments. There's no, you don't waste perfectly good gold leaf on crap.
She also proposed the idea that energy was conserved and worked out the formula for.
Right, and they all had said that already. So that this was just such nonsense that she worked out some formula, or there's something to do with conservation of energy. Everybody already was talking about it.
Gravitational potential energy. Some have considered her work as the time where the importance of energy began to be appreciated.
No, it was just a terrible confusion, okay? The physics, science was so messed up, and they'd have contests, to solve the problem, but obviously all of that doesn't work because the people judging weren't smarter than the people entering. So what's the point? If the judges know less than the entrants, what's the point? So it didn't resolve anything.
And formalized. No one individual can be credited with developing the idea of energy in all its forms.
Well, I suppose that's true, but again, it's not this form thing. It's just once you have the idea that it's the same energy, and as you said, it's just translating, okay, into different forms, but it is a cycle. Gravity consumes the little bits and consolidates the energy, and then heat radiates the energy.
It took decades to work it all out and included input from famous physics names like Carnot, Joule, Bernoulli, Boltzmann, Maxwell, and many others.
Right, and they all were kind of religious kooks, and they believed all kinds of wacky crap. So what is there to say? It's all garbage, okay? What they don't have is nice, solid, hard evidence. What they never did was see, well, what happens if I drop 4 pounds 1 foot and I drop 1 pound 4 feet? What happens? Is that the same energy? See, the 4 feet is really only twice the velocity. That's the catch. because it's only in the gravity twice as long. So even though the distance is 4 times as much, it's only in the gravity twice as long. And gravity is 9.8 meters per 1 second. It's only 2 seconds. It's only 2 units of energy.
In the modern world, we can think of kinetic energy as things that move, like translate, rotate, and vibrate.
So it's more just talk, no experimental evidence. So why don't you show us a ballistic pendulum and say, look, see, 2,000 joules goes in. We collect 1.8. Yes, 1/1000th of the energy. Isn't that miraculous? With all of our technology, the best we can do is maybe 1.84. Yeah. Less than 1/1000th of its energy is what you're collecting. And that's, you're going to tell me that you know what the hell you're talking about. And if they collected anything more than 2, right? So if they collect more than 1% of the energy, anything more, then they made free momentum. They have a free energy machine.
And potential energy being when an object is moved against a force. That force arises from some sort of field interacting with...
So some sort of field, some sort of blah, blah, blah. So we all know that it's the speed of force. Come on. All the forces go the same speed. It's not about light alone. And it's just that simple. A force acts on electrons and protons, and it shares its momentum with them.
Some kind of charge. Examples include an electric field and charge, or gravity and mass.
So an electric field, again, I would argue that we don't sit there and pretend that the voltage is squared.
In cases like those, if you release objects, they will begin to move, and this will transform that potential energy into kinetic energy.
So more nonsense with the same example, and it's about how long the rain is hitting it. It's how long the sun is shining on it. That will decide how much energy it collects.
Energy. Now, just why energy is such a big deal was originally...
So it's sort of a big deal because you should understand the concept of push and pull. And energy is basically saying, yeah, that's right, you got to hit something. And there's no pulling. There's just hitting.
Originally pretty mysterious.
And sticking, of course.
It only became clear when German mathematician Emmy Noether realized...
They always bring this one up, and I don't understand the point of it at all. The whole thing doesn't say anything that you don't already know, so what's the point? I don't know. But I'll use it to my advantage in a second.
Something enormously profound about the universe. She realized that conservation laws were a consequence of symmetries in the laws of nature.
So this silly concept of symmetry next to the word conservation, when yes, you draw a circle, it's symmetrical. It has to be symmetrical or it wouldn't work. Duh! So it's just too ridiculous.
If the laws of nature...
What goes up comes down. Oh yes, that's symmetry. So what?
Nature, well, unchanging over time, and I mean the deeply fundamental laws of nature, then energy would be conserved. That is to say, unchanging.
Yes, we already knew this, right? You just point out how Descartes already demonstrated it. So, and I can go back to Descartes saying it. So what's the point? Yes, energy is conserved. The same motion is in the universe. It's just going from thing to thing. Known fact, we don't need Nutter.
It also showed that if the laws didn't change with location, then momentum would be conserved.
There you go. So that's the irony of it, right? So she basically was telling you that momentum is the real thing and kinetic energy is nonsense because it won't be conserved. That's the big joke here.
But that's a topic for another time.
Yeah, see, yeah. So I have to pile on a bunch of rationalizations to explain why she was right but completely wrong.
And I made an entire video about Emmy Noether, which you can watch if you're interested.
That won't have anything to do with reality again or any real experiment. Oh.
I put a link to it in the description below.
I'm just waiting.
So I've told you
breath.
the physicist's definition of energy, and I gave you a rough definition of...
So just mush, mush, mush. All you've done is talk mush. You haven't shown a single bit of experimental evidence. I can show the Mythbuster car crash, or I could just play that. 100 miles an hour into a brick wall, 50 miles an hour into a brick wall. No sign, absolutely zero evidence of even an indication of anything more than twice the damage.
What kinetic and potential energy are, and I ended up telling you why energy is conserved. Is that it?
You didn't tell us why it's conserved, but you didn't explain the mechanism of the conservation. That gravity creates heat, the heat goes back into space, which pushes on another stellar object and causes more pressure and heat. It's a heat cycle. And the fact that you can make complicated things, in between, you can create little eddies in the stream and all that stuff. Well, who cares? The eddies still have, as the net consequence, energy going down the hill.
Done? Well, not yet. For one thing, so far what I've talked about are objects with mass. It's not only mass.
So obviously this is where physics just makes shit up and we're all supposed to believe it for no good reason. So they have no good reason to say photons have no mass. There's just zero evidence indicating they have no mass. And there's every bit of evidence that they do create momentum, they do exchange energy, and there's just no reason to say zero mass, because it makes no fucking sense, sorry. No sense at all to say it. Because we know they carry momentum. You can't have a 0 times your velocity. It doesn't mean anything.
Massive objects that can have energy. Massless photons also can.
So nonsense. So massless photons can have energy which doesn't fit with either kinetic energy formula or momentum. It just breaks the whole continuity of any kind of reasonable statement. There's absolutely no good reason to say photons are massless. No reason.
Carry energy. Photons are moving ripples in electromagnetic fields.
Says you. Okay. And really. Not even close to any fucking evidence or pictures of that. Ugh. God, this is so annoying. Laser beam, laser beam, laser beam, laser beam. I mean, come on. It's just, we already know there's no spreading waveaton.
So moving fields have to be added to the list of objects with energy.
So we already know that the fields are just any kind of radiation moving from point A to point B at the speed of light will cause an impact when it arrives.
And of course, Einstein showed that mass and energy were equivalent and mutable.
So again, that's just nonsense. So the only reason why mass has anything to do with energy is because mass displaces energy. So I've used this analogy before, but I mean, you could get in your bathtub and you displace the water. The water now has a higher water pressure, okay, because of that displacement. So you can make lots of arguments about the fact that when you displace space, there was force that could fly through that space, and now it can't fly through that space. So now it has more pressure because it's going to hit more surfaces. So if I have a box and I fill it half full with a cannonball, the energy is now more energetic because it's hitting surfaces twice as much.
And you can change one into the other and back again. That doesn't make much sense from a classical point of view. After all, a stationary and massive...
Right, and so there's no good reason to believe it. And again, it's just a story they tell. You're not going to get any physical evidence for the story.
Object in outer space, far from all gravitational fields, has mass, but it isn't moving. So in my example, it has neither kinetic nor potential energy, but it does have mass.
So more nonsense, and now they're going to do this filling in space thing. So objects are moving away from us at tremendous speeds, but they're really not moving. They don't have any momentum because space moved them.
If mass is energy, then something isn't making sense, since energy is present without kinetic or potential energy being present.
Right, and so gravity, which you don't think is a force, is creating pressure and heat, so it's making free energy by your theory. That kind of proves the whole thing is bullshit. Realistically. Alright. Oh, I think the garbage is here. I have to go collect my can. So, I shall be back. Yeah, should be back. Yeah, so, I was just thinking that, as a kid, they never said any of this stuff like gravity causes heat. There was never a connection between this kind of obvious fact that the heavier something gets, the hotter its core gets because it has all this energy pushing towards its center, all this momentum. And strange that physics missed something so obvious. And again, it's like the strong force. Why would you invent some idea that you have to push protons into each other when you have this simple idea that you just stick an electron in there and the two protons snap right together? No problem.
The situation is resolved when you look deeply into the fundamental nature of mass.
So, this really will go to, I'll do another video. Since we're talking about energy, it's sort of related. But fusion won't work, ever. Because theoretically, the hydrogen atoms don't have a whole lot of energy. They're expanded, okay? And what this gravity is going to do is contract them, and that's applying energy, all right? So without applying it, that is, without creating neutrons, it can't build a helium nucleus. And so you can't start with hydrogen, expanded things, and then say, well, I'm going to make energy, because it doesn't have any. You haven't compressed it yet. So the compression energy will always exceed the energy you'll get back from the expansion. It takes work to push the magnets together. And you can't get the pop, okay, from the magnets flying apart without putting the energy in to push them together. So you can't get back more. You won't exceed unity.
When you do that, you find that ordinary mass is located in the mass of protons and neutrons, and when you look into where their mass comes from.
So just nonsense to worry about this mass problem being any kind of problem at all. We know that the energy is only in two states. It's either pushing a mass, it doesn't matter whether it's 500 pounds or 50 pounds. We know it's going to have an MV, a mass and a velocity in the end. And the force, you need a lot of force to push a heavy particle. You need a little bit of force to push a light particle. Not complicated.
It comes from the motion and forces governing nearly massless object inside protons and neutrons.
So nonsense. There's no massless particles inside of electrons and protons. The electrons and protons have no energy until a force pushes them. That's their only capacity to have anything called energy. A nuclear bomb does not release quarks. That's not the power of the bomb. The power of the bomb is the fact that it keeps knocking the electrons out of between the protons, and then the protons see each other and fly apart. It breaks the magnetic bonds of the atoms. That's why a nuclear bomb works. It's breaking magnetic bonds.
Indeed, the nuclei that make up each and every one of us are tiny vortices, subatomic.
So this is all made up, vortices. There's little tornadoes, all made out of little love tornadoes. Yeah, little love tornadoes. Oh, God. This is the gayest play ever written, physics.
Tempests of moving and nearly massless particles held under strong forces. I made an entire video
that was just a piece of made-up pile of crapola. Has nothing to do with evidence. We just make up crap. It's the magical beetle. I mean, this is like somebody 1,000 years ago. And everything's magical.
Goes into this, and again, the link is in the description. If mass is just energy swirling in a single location...
No, mass is not swirling in a single location. Mass is pushed. It consumes the force. It captures it. It takes it out of the object. If I throw a boat in the Mississippi River, I'm slowing the river down, okay? So I'm taking energy from the river. If I'm falling in gravity, I'm consuming the force that would have hit something underneath me. Okay, it's just a fact, and all of a sudden its gravitational potential is changing. They actually have some evidence of this. You know, when you drop something, the ground actually at the last minute pops up to meet it. Yeah, because you've consumed the force that would have hit it. But then when you show up, all of a sudden all the force shows up with you. All the force you consumed is now hitting the surface just as it would have if you didn't get in the way in the first place. You just transmit the energy to the end product. So if I put a boat in the Mississippi River, I slow the river down a little tiny percentage, and then when I get to the end of the river, I sit there and sink the boat into the ocean. I'm putting the energy back.
With a swirling energy not moving, basically a stationary tornado.
Again, a stationary tornado. This is physics. This is science. The stationary tornado theory. This might as well be talking about burning bushes, right? What's the difference? The stationary tornado or the burning bush? Oh, what a tough choice. What sounds more scientific? Ugh.
And we're back to the definition of kinetic and potential energy. That swirling thing isn't a perfect description, but
it's not even it's not even close to the truth.
reasonable mental image and good enough to get a rough idea.
No, it isn't. It's a terrible idea. It's a completely wrong concept. There's no swirling anyway. Nothing can swirl without some container to be causing the bending and all that kind of stuff. There's straight lines. That's what physics is made out of. Push and straight lines. Push, straight lines. Push, straight lines. That's the real universe.
Yeah. And that's almost the entire story. Energy is motion and forces, and it's unchanging, sloshing into this form and that.
Okay, it's unchanging, right. But how does that make sense with your bent space theory? You're saying bent space gives objects momentum. So that's the river, the bent space. That's the energy. And then the bent space, the object hitting the earth heats the earth, and then the heat radiates as real energy. So you have non-energy creating real energy. You get where you have a continuity problem, bozo? You can't talk about conservation. How do I turn the heat radiating from the earth, how do I turn that into bent space? Exactly.
Is somewhat analogous to how the atoms of the universe can change form, like how dirt becomes grass, becomes a cow, becomes a person, which becomes dust and
whatever. This doesn't really have anything to do with, but yes, the cycle of carbon or oxygen or anything in the environmental biosphere is also a conservative system. But as evidence sort of proves, that conservation is just in theory and ideal. Because what happened on Earth? Well, a bunch of organisms didn't completely decompose and they didn't give their atoms back to the environment, and instead the atoms sunk, and they would happen to be a bunch of hydrocarbon, and all of that, okay, got sunk into the ground, wasn't in the cycle anymore, and the cycle turned colder and colder and colder, and then we released a bunch of it. Now it's warming up again.
The cycle renews. There's one final twist to the whole thing. While energy is often said to be conserved because of Noether's
Oh, fuck this Noether crap. Oh, look at that, a monocle. I guess it's just a photographic defect, but she looks like she's wearing a monocle.
Insights about the symmetries of the laws of nature.
Again, this is, who knows what this bullshit is, but I mean, the idea of conservation and symmetry, these are almost the same word, so what's the point?
Energy conservation isn't 100% true. The universe is expanding, and it's filled with a field.
So he's going to do this thermodynamic nonsense that somehow there isn't the gravity thing making all of those things glow isn't conserving the energy, when it's, of course, isn't eating the entropy. Every one of those stars and galaxies is eating entropy right now. It's converting bent space, which is really just radiation, into a heat we understand. or heat we can see. Heard a car horn. I don't think it has anything to do with me though. Okay. Yeah, finishing.
Of constant energy density. Constant density and expanding volume means that the
So again, the expanding volume thing all depended on redshift, their interpretation of it, and their theory is that a bunch of space is poofing into existence all over the place, and everything is moving away from everything because a bunch of extra space is being created. So nothing's really moving, it's just being displaced in its position for free, and it gains no energy from that process. Well, whatever. It doesn't make any sense.
energy of that form, which is called dark energy, by the way, that energy is increasing. In an expanding universe.
How? Why? What do you mean increasing? What does that mean? Maybe you can turn the dial down and decrease it.
Energy isn't conserved. Furthermore, when you talk about the fact that distant galaxies look redder than they should because of the expansion of space.
That's the same subject, so he made it sound like this is some different subject. No, the whole reason why you believe the space is expanding is because the objects appear to be moving away from us when, no, you could logically understand that the light has traveled a very long distance and it has been scattered.
That has a consequence. You see, the amount of energy carried by light depends on the color of light, and the redder light has lower energy.
So that's just another canard. It all has the same energy. So I could bang a drum, bang, 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 bang. Or I could bang a drum, bang, 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 and be done. Same energy, same bangs on the drum, same force, same everything. Okay, the two sound different. Okay, they have a difference, the frequency difference. But it's the same total amount of energy. And yes, it makes a difference. If I want to knock something over, I have to hit it while it's still moving away from me if it's hard to knock over. If I need more than one unit of energy to knock it over, I have to hit it and then hit it again while it's still moving and then hit it again while it's still moving. That's the difference between the frequency. So it's really just, again, this is so trivial, but they think because applying all the energy in a short amount of time has a different effect than applying the energy very slowly. So if I took a nuclear bomb and instead of allowing it to explode very quickly, I did it all very slowly over months, it's the same amount of displacement of material, the same amount of stuff moving. All right, and I just slow the whole thing down and I can use it to light light bulbs and do all kinds of things with it. But if I let it happen really quick, then it breaks everything, everything's fucked up. Doesn't mean the bomb has more energy. It just means that the energy is being applied to systems that can't tolerate. They can't consume it without breaking. The fact that it breaks doesn't prove it has more energy. It means you applied the energy. Again, this mug can be shattered by ultrasound. I can hit it with a little bing, okay, and the whole thing will shatter. Or I could sit there and put an elephant on it and it won't shatter. So I can put more energy on it and it won't break. But if I apply the energy in just a specific way, I can fracture it. It doesn't mean that the small energy had more energy. It means that I applied it in a way that wasn't consistent with this medium. It wasn't allowed. The medium can't transmit it. It can't absorb it. And it breaks the atoms. It breaks down the chemistry of the object. That's not having more energy. That's just applying the energy in a different way, which can cause a different effect. It's just bullshit. Annoying bullshit.
Thus, it appears that photons of light from distant galaxies have less energy than they did when it was emitted. This implies that
So it's just not true that they have less energy. It just means they have a longer frequency. But the fact that they have a longer frequency is in fact a consequence of the fact that they have interacted with matter and it's changed the configuration of the energy.
in cosmological situations with a changing shape of space-time, energy is also not conserved. And this is a universal truth. In general relativity, in which the size and geometry of space...
So it's not conserved. So again, what's the point? Your relativity theory says energy is not conserved. Your other theory says it is conserved. Professor Lewin says nature can't finagle momentum. Yet, yes, it can. I mean, what's the answer? I mean, these are contradictory statements.
Space and time are unchanging. Energy isn't necessarily conserved. You see,
it's still conserved. It's just displaced over a larger area. So it's the same amount of energy. You just spread out the area that the energy is in.
Noether's insight relied on the mathematics of unchanging space and time. Release that condition, and Emmy's mathematics no longer applies.
Yeah, so, and again, her mathematics led to the conclusion that momentum is conserved. Uh-huh.
The lack of conservation of energy in general relativity is a complicated one, probably worth a video or two of its own. However, that's not the topic of this video.
Oh, right, and it doesn't really matter. You're just contradicting yourself all over the place, so what's the point? So throw out the second law and the third law, so you might as well throw out the first law. You might as well just throw out all the rational physics and just go complete wooey shit.
I put a link to a website that talks about it if you're interested.
Well, I want to see a link to a website that shows about it. I want to see evidence. I want to see it taking 25 times the fuel to spin something 5 times as fast. I want to see you go out to your car, all right, and pour in 25 times the gasoline because you're going to go 50 miles an hour instead of 10 miles an hour. I want you to show me.
But be warned, it can be quite technical. So, at the deepest known level of reality, what is energy?
For physics, it's made up stupid shit, okay? For the rest of us, me, the rest of the human beings who aren't doopy jackasses, energy is motion.
It's force fields and objects that interact with it.
Yeah, there's force. It has the energy, and it can give it to matter. Not complicated.
Potential energy. Kinetic energy is the motion of the fields. Remember that mass is mostly moving.
So more nonsense about the motion of the fields that don't have any mass. The kinetic energy of the fields with no mass.
Fields. That stationary tornado thing.
Yeah, the stationary tornado thing. The burning bush.
Kinetic and potential energy of all kinds slosh back and forth.
Oh, brother. Slosh back and forth
Into one another in an endless dance, changing identity, but never changing the amount, forced to be the same.
There we go. So he's back to conservation, and he just said there is no conservation. So what's the point? Just gibberish.
Same by the mathematical structure of the laws of motion.
The third law, which you violate with your formula explicitly. The formula explicitly violates the third law. Every time somebody shoots a gun, they're violating Newton's third law. Just a fact. So why talk this shit?
That is, unless you're talking about the universe as a whole, and there, energy conservation is a more complicated thing, requiring that you revisit the meaning of the words energy and conserve.
Oh, yes, we have to revisit the word you just described and defined for us into some other kinds of benergy, smenergy, good energy, what?
From one point of view, energy is terribly complicated, while from another, it's breathtakingly simple.
Yes, the rational point of view, it's really simple. Force going the speed of light gives motion to dead matter that doesn't have any velocity until you push it.
It's a delightful...
There's rocks, and then there's Sisyphuses. Okay, the Sisyphuses can be flying around, going really fast when they don't have to push any boulders, and then when they have to push boulders, it's kind of a dull process. They gotta go much slower. It really sucks.
Dizzying topic with layers upon layers, and one that is always...
No, it's just not. It's just so goddamn simple, and you have just ruined it with all this phantasmagorical gingerbread house bullshit. And look how happy he is about it. I love fooling people and making crap up and getting them all to believe it. It's so much fun being a bullshitter.
Fascinating. Okay, so that was an incredible topic with...
Oh, brother. Okay, enough of that. All right, we'll call it a video. Oh, gee, that was so bad. So fucking bad. All right, but he did, right there in front of everybody. He brought up the Deschardelet denting clay experiments. Okay, an experiment, like I said, that any physicist who wants to have any credibility has to admit that's a theoretically flawed experiment. It's like making low friction carts where you're going to measure the linear motion, the velocity, and they have little tiny metal wheels. It's theoretically not the best choice. A smart physicist doesn't, make that mistake. All right. Till the next time and such. And so forth and whatnot. Okay. So bad. Yeah, really. Maybe I'll go back to this. Just for the flaming text. Ooh, flames. They really just don't understand that heat is the same as all the other forms of energy. It's the same stuff. It's stuff moving, and it's all that matters. Movement is all that matters.